All right, I'm going to finish up working through the quadratic formula word problems. We did number 1 and 2 in class, and I'd like to just go through number 3, 4, 5, and 6. Some of the work I'm going to do is going to be on line paper. I've got a calculator next to me as well. We wrote the equation for 3a by substituting the initial height and the velocity into the equation. You had left class with that. It says use the quadratic formula to find out how long the rocket will take to hit the ground after it's launched. So we're looking for, this is the place where the rocket is launched. Oh, it's actually launched off a cliff. So we're looking for the 0 that is on the far right of our parabola. So what I'm going to do is I'm going to identify my A. I can tell already I'm going to go to line paper because I don't have enough room for my quadratic formula work. My A is negative 16. My B is 116, and my C value is 101. So in the quadratic formula, my x's or my zeros are going to be found by negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to start my process of simplifying. X is equal to negative 116 plus or minus. You're used to seeing me do all this. There's my negative 32 down there. Going to my calculator, 116 squared is going to give me 13,456. I'm going to do a negative times a negative. I'd be adding to that. 4 times 16 times 101, 6,464. Negative 116. Let me find that sum under the radical. 13. I'm getting 19,920. Divided by negative 32. And I was over on my calculator finding the square root of 19,920. And actually 19,920 does not have a very friendly square root. They want this rounded to the nearest tenth of a second. So when I get here, what I'm going to do is separate my two solutions, negative 116 plus radical 19920. This is about 141. I'm going to wait a minute until I do something with that. This is going to result in a negative answer. I can tell that because when I add this to my 141, it's going to be a positive value up top divided by negative 32. So there's no way this is going to get me at the solution. Let me do the other solution, the minus radical 19920 all divided by negative 32. I'm going to put this in my calculator as a group, negative 116 minus radical 19920. I'm going to close up those parentheses and find out what it's equal to. And then I'm going to divide it by negative 32. And I'm getting that it's about 8 seconds, 8.036. So that's approximately 8.036, although wait a second, they said round to the nearest tenth, 8.04 seconds. So there's number 3 in its entirety. Number 4, you and a friend are hiking in the mountains. You want to climb a ledge that's 20 feet above you. The height of the grappling hook you throw is given by the function h of t equals negative 16t squared minus 32 plus 5. What's the maximum height of the grappling hook? Well, this has to do with the maximum height. What I need is the y value of the vertex. How high can I get it? So the first thing that I'm going to do is identify the vertex. I'm in standard form. So the x value of the vertex is going to come from the opposite of our b divided by 2 times our a, which is going to be 32 over negative 32. So our vertex is going to be at, that doesn't make sense, the y value of the vertex. Let's see. Am I doing something wrong here? X, y value of the vertex. The a is negative 16, the b is negative 32, the c is 5. I think I'm okay. Negative b over 2a, 32 over negative 32. X value of the vertex is at negative 1. Guess I'm going to have to put in negative 1 to find out what that y value is for that height. Negative 1 squared minus 32 times negative 1 plus 5. And I can actually put this entire value. So the vertex is happening at in time that has passed, -1 to the second power minus 32 times -1 plus a 5. It's going to happen at 21 feet high. So to answer the question, can you throw it high enough to reach the ledge? You sure can, because the maximum that you can throw it is 21 feet. Number 5, you're trying to dunk a basketball. I think we're looking for a maximum again. What's the maximum height? So my A value is -16. My B value is 12. The C in the standard form would be 0. -B all over 2A. -12 over -32. That's going to reduce to a nice decimal, I believe. Sure did. 0.375. It would take you 0.375 seconds to get to your maximum height. Put that time in order to find out what that actual maximum height is. 0.375 squared plus 12 times 0.375. So -16 times 0.375 squared, and I'm doing it all in my calculator in one foul swoop, using parentheses. That maximum height is 2.25 feet. Will you be able to dunk the basketball? Nope. Your maximum height that you can jump is 2.25 feet. You're not going to get to the 2.5 jump height that you need. Number 6, diver standing on a platform 24 feet above a pool. He jumps from a platform with an initial upward velocity of 8, looking to put that in. Yep, absolutely. We have the starting height of 24 that I read is going to go in for S. So height based on time is going to be -16t squared plus the velocity times t plus the starting height, which is 24. How long will it take him to hit the water? We're looking for that 0 over here. The positive 0. I'm going to use the quadratic formula. -16, 8, C is 24. Let's see if I can make this fit the page. -B plus or minus radical B squared minus 4 times A times C all over 2 times A. Start my simplifying. -8 plus or minus radical all over -32, 64 plus 4 times 16 times 24. I know I'm going to be adding that because it's negative. 1536 plus 64 under the radical is giving me -8 plus or minus radical 1600. Nice, I like this one. Friendly. I think I can have some room here too to finish. -8 plus or minus the square root of 1600 is 40, all divided by -32. My two solutions are going to be -8 plus 40 over -32, or -8 minus 40 all over -32. I know it's going to be this one because this would wind up with a positive divided by a negative result. That's not going to happen. I've got -48 divided by -32. That took him 1.5 seconds. Cool. Good luck.